Hi, my name is Dino Tinitigan, and today I will give a short explanation on what SMP is. SMP stands for Smart Modular Platform. It is a platform that is designed to be used in any application such as robotics. It first started as a senior design project, and we ended up using SMP to develop and create a smart wheelchair which can be controlled with the head and had wireless telemetry and a bunch of sensors. Okay, here is a block diagram of SMP. Here we have a central data fusion module, and connected to that data fusion module is a bus, and connected to that bus is a bunch of slave modules, and each of those slave modules can have their own sensors and or actuators. I'll talk a little bit more about this bus later on. But essentially, the bus lets me connect a bunch of slave modules to a single serial bus and lets them share it without having any problems. It's a little bit different than I2C, but essentially it is slave initiated, so the data fusion module doesn't have to ping each of the modules, and what happens is whenever the data is ready for the slave module, it sends it as soon as possible to the central data fusion module. Anyway, another thing that can be connected to the data fusion module is an XB, such as that can be used for wireless control and or telemetry, and also a motor controller. Now the data fusion module is responsible for gathering all the data together from the slave modules and then performing the necessary actions for them. Okay, so here we have the box of the implemented SMP. For this one, this is the motor controller, and the motor controller I used is Dimension Engineering Sabertooth 2X50 HV, which is a pretty powerful motor controller, and it can handle I think 50 amps continuous current and about 100 amps peak currents. So the data fusion module is this white thing over here. Here you can see I have the XB, and here is what I have is a buffer, and what this buffer does is essentially change the 5-volt signals from the whole circuit and change it to 3.3 volt signals, which the XB uses. And underneath this XB is the actual microcontroller. Right there. And the microcontroller I'm using is a Atmega 1280, and the whole circuit is actually based on the Arduino Mega. So moving on, here we have the power supply and the relay circuit for the robot. And right there is a microcontroller. So this is an example of a module that I implemented, and I call this the Smart Power Module. And all it really does is just read the voltage levels of the battery, and then sends that into the bus, the data into the bus, and into the data fusion module. So connected to that data fusion module is a ribbon cable, which connects to another board. And this board is I call it a module interface board, but all it really does is just break out the wires so that I could connect multiple modules into one bus. And also connected to that is to the data fusion module is a bunch of wires, which is connected to the serial cable. The serial cable connects to this box right here. And inside this box is just another module interface board. And then I decided to use the RJ45 ports so that I could connect modules to it. So here is an example of a module. Here I have what I call the environmental module, and what it essentially has is a temperature and humidity sensor. And that data is, once this guy has data, it sends the data right away when the bus is free to the data fusion module. And each of these modules just connect like so. And once they're connected, they get power and all the necessary connections to the bus. Here's another module, which is the GPS module. And the bus itself is designed to be a plug and play, so I can just remove and add modules as I wish, as long as I have the necessary code in the data fusion module built in to handle the data that the module will send it. Okay, so let's open a terminal application such as Buddy. And since the XV is in COM11, we're going to put it in COM11. And we're going to set the baud rate at 38,400 bits per second. Okay, now we're seeing some data from the data fusion module. And right there, we just saw the environmental module, the GPS module, and then the smart power module. So the way it works is whenever its data is ready from a slave module, it checks the bus if it's available. And the moment it becomes available, it sends data right away to the data fusion module. This way, the delay between gathering the data from the sensors to the time the data fusion receives it, it's very low. So the latency is really low. Compared to a protocol such as I2C, the master module or the data fusion module will have to check each module, and then the module will react then. So this is when our protocol will be useful. Here we just we're using the control module. So here I'm pressing the keyboard, and the keyboard can be used to control the motors. So it can receive and send data both ways. And I can also enable and disable other options such as the CAS or the collision avoidance system. And I can also enable and disable debugging mode. Debug is re-enabled again, and then there's a control module again. And certain options such as recovery option just resets the system.